All right. Good afternoon, everyone. I hope you can all hear me.
Yes, sir. Good afternoon, sir.
All right. I welcome you to today's class. Okay, thank you. I see some chat. Oh boy. All right. So today we'll be looking at something very briefly: microservices and its architecture. Yeah. And after that, we'll go straight to our tests. Well, of course, I had a number of you saying that you want to drop the course. Well, that's okay for me. At least I'll just have to grade very few scripts. Yeah, having almost 80 students is a lot of stress. So I will advise that probably 40 or 50 of you can drop so that I can have very few scripts to mark. All right, uh, so let's start with a form of introduction. Now, the last week we looked at cloud services, and of course, we looked at software as a service, and we looked at some of the characteristics here and there. So today we'll continue in that direction. We look at what microservices are and why it's important that we use them, and a host of other stuffs that is related to microservice and microservices. So a software service is a software component that can be accessed from remote computer over the internet. Given an input, the service produces a corresponding output without any side effects. And this service is accessed through its published interface, and all details of the service implementation are hidden. Now, services do not maintain any internal states. So state information is either stored in a database or is maintained by the service requester. All right. So when a service request is made, the state information may be included as part of the request, and the updated state information is returned as part of the service return. We're going to be seeing how these requests are made and how it is returned. Now, as there are no local states that of the services, services can be dynamically reallocated from one virtual server to another and replicated across several servers. Okay. So after various experiments in the 1990s with service-oriented computing, the idea of the big web service emerged in the early 2000s. Now they were based on XML protocol and standards such as SOAP for service interaction and WSDL for interface description. Now most software services don't need the generality that is inherited in the design of the web service protocol. So I think I should have done something on the web protocol as it were. Yeah, sorry, I think I'm getting so many messages. Sorry, I just want to check. All right, sorry, it's from the other class I just left. Consequently, modern service-oriented system use simpler, lighter weight service interaction protocol that have lower overhead and consequently they are fast in their execution. So what are microservices? They are small-scaled, stateless services that have a single responsibility. So that is the bottom line of this. They have just one responsibility. Now they are combined to create applications. So a number of them can be put together to achieve the creation of a single unit or a single feature in a software component. Now, they are completely independent with their own database and UI management code. Software products that uses microservices have a microservices architecture. So if you need to create cloud-based software products that are adaptable, scalable, and resilient, then it is recommended that they are designed around a microservices architecture framework. So let's look at a microservice example. For instance, we want to break down system authentication into microservice. So we could have a user registration where users provide information about their identity, security information, mobile number, email addresses, right? That's one microservice. Then authentication using UID or password. Then you could have a two-factor authentication using code sent to your phone. Now user information management, that is change password or mobile phone number. Then there can also be a provision if you forget your password to always reset it. Sure, a number of us would have interacted with such systems on the reset of our passwords, especially on our mail or social media handles. Now, each of these features could be implemented as a separate service that uses a central shared database to hold authentication information. However, these features are too large to be microservices. So that's a major problem. So how do you draw the line to fixing a particular action or feature as a microservice? Now, to identify microservices that might be used in the authentication system, you need to break down the coarse-grained features into more detailed function, right? So that is what we like. You have what in your, I think in your project, you have what is called methodology, I think. So a methodology covers about, okay, let's assume that for every objective that you have set to achieve your aim, then a methodology will be developed. A method or a methodology will be developed to address each of the a methodology will be designed to address each of the objectives that you have set out to achieve. Now, you could now come up with, like if you have objective 1, within the methodology to achieve objective 1, you could have several methods, right, to achieve the set out objective. Just one objective, you can have several methods to achieve it. For instance, if you need to acquire data, right? If that's your first objective, to acquire data from a different location, right? Now, the method you may use to get your data from one location may be different from the method that you adapt in retrieve or getting your data from the other location. So though the objective is to get data, but the methods for getting data from different people or different data sets is different. So it also applies to microservices. You could have a huge feature, right, that could be further broken down granularly into maybe unit functions that can be easily implemented into a micro service, right? So functional breakdown of authentication features, you have the user registration component, and you have the authentication using the UID or password. So the user registration, you set up a new login ID, right? Once that is completed, the new microservice is also set new password. That means, they will tell you to type a password that you are conversant with. And sometimes they may be very strict on the order of their password, that some may have, they may be alphanumeric, right? Some may be, maybe you have a special character to be included in one of it. So once that has been verified, then you set up a password recovery information. Then for further security, you can set up a two-factor authentication where a unique set of code will be sent to the mobile number of that individual or to the email of that individual. Now the person can now click on the link that has been sent to his mail to ascertain or to continue with his registration procedure. Then after that, the registration is confirmed. So what this has done is to break down the user registration, which is a methodology, into smaller methods, which can be easily put into microservices. So also for the authentication, it has been broken down in that manner. So for authentication of microservices, so you have the authentication broken down into UID management, password management, user information management, then the data accompanying them. So what are the characteristics of microservices? They are self-contained, they are lightweight, they are implementation independent, they are independently deployable, and of course, they are business oriented. So how do individual microservices communicate? So microservices communicate by exchanging messages. So that's the initial introduction that will say it puts like an information in the header. Then one is being returned. This the requested information is also put as part of the message. So a message that is sent between services include some administrative information. I'm sure you have done something on data communication, right? So administrative information, the service requests, and the data required to deliver the request. So this can be seen properly in data communication. So services return a response to service request messages. So an authentication service may send a message to a login service that includes the name input by the user. Now, the response may be a token associated with a valid username, or might be an error saying that there is no registration for this user who is requesting a login, right? So what are the characteristics? Now, a well-designed microservice should have high cohesion and low coupling. Now, cohesion is a measure of the number of relationships that parts of a component have with each other. High cohesion means that all of the parts that are needed to deliver the component functionalities are included in the component itself. So coupling is a measure of the number of relationships that one component has with other components in the same system. Coupling is a measure of the number of the relationship that one component has with other components. Now, I think is it data? I think is it data communication or this one-to-one, one-to-many, broadcasts this mobile communication, where you have several types of relationship, one-to-one, one-to-many, one-to-this, and all that. So low coupling means that components do not have many relationship with other components. So each microservice should have a single responsibility. That means it should do one thing only, and it should do it very well. However, one thing only is difficult to define in a way that is applicable to all services. Responsibility does not always mean a single functional activity. That's why we have decomposition into more fine grained, so that we have distinct method for achieving one aim or one of the set out objectives. So let's look at password management functionality. So the user function, create a password. Another fine thing is that change the password, check the password, recover password. Now, supporting functionalities, you have check password validity, right? That means, does this password conform with the set protocol used by creating their own password, right? You know, sometimes if I need to register for a particular, maybe group or something that is academic in nature, now once they start giving me rules and regulations about how their password should work, I just run away, because usually one should start with a capital, the next one should start with figure. They'll just give you, and oftentimes you just forget the password as soon as you are done with the registration. So you have to reset the password all the time. So another one is to delete the password, backup password database, recover password database, check database integrity, repair password. So these are the supporting functionalities. So each of these is doing just one, is performing one function. And as it was said earlier, it should do it very well. So microservice support code, you have the microservices, then the service functionality, well-defined, then other supporting functions like management functions like message management, failure management, data consistency management, UI implementation, and all that. So those are the supporting code for microservices. So what are the architecture? The microservice services architecture is an architectural style, a tried and tested way of implementing a logical software architecture. This architectural style addresses two problems with monolithic applications. The whole system has to be built, to be rebuilt, retested, redeployed when any change is made. Now, this can be a slow process, as changes to one part of the system can adversely affect other components on that same system. As the demand on the system increases, the whole system has to be rescaled, even if the demand is localized to a small number of system components that implements the most popular system function. So what are the benefits? So microservices are self-contained and run in separate processes. So in cloud-based system, each microservice may be deployed in its own container. I think we did something on container, I think the last class or upper class. Now this means a microservice can be stopped and restarted without affecting other parts of the system. Now, if the demand on a service increases, service replica can be quickly created and deployed. Now, these do not require a more powerful server. So scaling out is typically more cheaper than scaling up. Right. Sorry, I'm trying to check. Okay. Yeah, so example is a photo printing device. So please give me a few seconds. I need to put on the generator. There's no light. That's a Nigeria factor. Mr. Lanite, can you hear me? Oh, everybody is sleeping. Hello, can you hear me? Can anybody hear me? Ah, have I been disconnected? Okay. Oh, thank you. I think I'm saying. Okay, Ajiwole. Thank you, Korede. Okay, yeah, we can hear you. Oh, thank you. Sorry, I thought I was logged out already. Yes, network issue. Oh, sorry, Mr. Lanite. Okay, yes, we can. So please, I need to quickly put on the generator so that I don't get logged out. They have taken, yes. So I'll be back in a few seconds, please. Thank you. Yeah, all right. I'm back. Can you hear me now?
Yes, sir. My network
All
threw
right,
me out,
thank
sir.
you. What do you say?
Yes, my network threw me out when you asked the question, sir.
Oh, so how do you want to do the test?
Network has been off and it's really bad, sir.
Please get to where there's good network. All right, so let's continue. Excuse me. So, example is a photo printing system for mobile devices. Now, imagine that you are developing a photo printing service for a mobile device. Now, users can upload photos to your server, one, from their others from their phone. Two, they can specify photos from their Instagram account that they would like to be printed. Now, prints can be made at different sizes and on different media. So if you look at that, this paragraph or those sentences, you find out that you could develop about 4 or 5 microservices out of those statements. So let's continue. Now, users can choose print size and print medium. For example, they may decide to print a picture on a mug or a t-shirt. Now, the prints or other media are prepared and then posted to their homes. Now, they pay for the print services or the prints either using a payment services such as Android or Apple Pay, or by registering their credit card with a printing service provider. So there are a lot of different services that could be munched out from this example that we have. So this a simple microservice architecture for photo printing system. So you have the system with the individual with his mobile app, right? And you have the services that can be provided. The individual can register through the API. It could authenticate, it could upload pictures, it could make payments using like a merchant, or register his pay card or credit card. Now you could print, and also you could choose the medium on which you want to print and the size of his printing. And of course, once that is printed, a dispatch can be made to that individual. So the key issues that we need to ask when designing the microservices are apparent. So what are the microservices that makes up the system, right? So you have, of course, in the first class or second class or third, we did something on the features, scenarios, and stories, right? So features, scenarios, stories will bring us up to speed with what is needed for us to determine which of these features can be broken down into finer grains, right? To make up different, or to give us different microservices that could just be handled by one, maybe one section of the code. So the next one is, how should the data be distributed and shared? So I think in determining the complexity of algorithms, as I've said earlier, the type of data you are going to supply to a system matters a lot. And it also affects the level of complexity of any algorithm or any program that you have implemented. For instance, you may design a system that could just pick up integers, right? But if you say you want to pick up integers, have you specified the type of integers? Are they positive or signed or unsigned integers? So the types of data you're going to supply into any program plays a major role in looking at the complexity of that system, and also in how effective the work of that microservice will turn out to be. So how should the microservices in the system be coordinated, so that how do they interact? Now, should services failure be detected, reported, and managed? So these are the things we'll be looking at generally. So how should microservices communicate with each other, right? So those are the design questions that you look at. So the first issue is, how should data be distributed and shared? What are the microservices that make up the system? How should the microservices communicate? How should the microservices in the system coordinate? So let's look at how to now go about the composition. We say that we need to balance, we need to give a situation in such a way that the microservice we want to develop should be able to solve only one problem and should be able to solve it well. So once we have, like, if you are doing like, want to calculate the complexity of an algorithm. Now, for those that have, I think we have linear complexity as a function of big O complexity. you have that they just have one statement. Now, however, for those that have cubic or quadratic big O notation as their complexity, that means they're having a loop or an iterative call on them. So for you to be able to break down a particular, so now what I'm trying to point out that if you have a loop, then what it means is that that microservice is not just handling one function, which has violated the rules of creating microservices. So microservice should be able to do just one thing, and it should be able to do that thing well. So how do we guide ourselves in the decomposition process? So the first one is to balance fine-grained functionality and system performance. Then the second one is to follow the common closure principle. Then associate services with business capabilities. Design services so that they only have access to the data that they need, right? So balance fine-grained functionality and system performance. Single function service, excuse me, let me get some water. All right. So single function services means that changes are limited to fewer services, but require service communication to implement user functionality, right? So this slows down a system because of the need for each service to be bundled and unbundled, to be a bundled and unbundled messages sent from other services. Then common closure principle, elements of a system that are likely to be changed at the same time should be located within the same service, right? So most new and change requirements should therefore only affect a single service. That means in a single container. Associated services with business capabilities. A business capability is a discrete area of business functionality that is the responsibility of an individual or a group. You should identify the services that are required to support each business capability. Now, design services so that they only have access to the data that they need. Now, if there is an overlap between the data used by different services, you need a mechanism to propagate data changes to all services using the same data. So we could have inconsistency of data, especially when there is a call from one service to another. So let's look at service communication. Sorry, I think there's a question also. Is at what point do we invoke the decomposition guideline? We went from key questions to decomposition guideline. Please help to clarify. All right, there's a question here that at what point do we invoke the decomposition guideline? Okay, now okay, let me go back to where that statement was made. I think it's the first or second. I'm trying to look for where that statement. Okay, well, sorry. I think when I was introducing, I said where did I from each features should be implemented as services. These features too. Okay, now look at this point. Sorry, the person who asked that question. Now look at the place I just highlighted. Now I said to identify the microservices that might be used in the authentication system, you need to break down the coarse-grained features into more detailed functions. So what we are doing here in essence is looking at how do you decompose those features or functionalities into fine-grained. These are the rules guiding the balance of the decomposition. So decomposition is just breaking them down into finer grains. That's all. I hope I'm able to address your concern. So service communication. Now services communicate. Okay, let me see. There's a question again. Oh, yes. Okay, that's noted. All right, thank you. Okay, so the individual responded. So service communications. So services communicate by exchanging messages. I think I still made a forward reference to a point where services we have to communicate. How do they communicate? Right? So service communicate by exchanging messages that include information about the originator, that's the person sending the message, as well as the data that's the input to or output from the request. So when you are designing a microservices architecture, you have to establish a standard for communication, right? That all microservices should follow. Some of the key decisions that you have to make are, so these are the conditions for creating an architecture for communication. Now, should services interact by synchronous or asynchronous means, right? That means, should their communication be a kind of store and forward communication or real-time communication, right? Should services communicate directly or via message broker? That means, can they communicate like one-to-one, or should they go through an interface or intermediary or a middleware? Now, what protocol should be used for message exchanged between services? Yeah, of course, for those of you who did networking, you are conversant with the TCP/IP protocol, right? Now, but I think for those in research of, those in the research of, what's the name? Health research and health informatics, telemedicine, e-health. Now you find out that the communication protocol for telecare, what's the name? Modalities, yeah, are different from the TCP/IP protocol. They are called the HL7 protocol. Now, that's a developed protocol for communication around the medical line. Now, of course, you also know that mobile communication has its own protocol, a little bit different from the wired TCP/IP protocol, right? So these are the considerations you should determine if you have asynchronous and synchronous communication. If there's going to be a middle person or direct communication, then what protocol are you going to use for your communication processes? So synchronous and asynchronous microservices interaction. So this is the first one where you have to decide that should they communicate synchronously and asynchronously. When there's a call from one microservice to the other, how should this interaction be conducted so that we do not have, I think, I'm sure you are doing database, I'm not sure. So if you are doing database management, there's a point where you have a problem of inconsistency in data due to accidental updates of a process that is being used, right? So, but if there is a method of communication that takes care of this problem, that emphasizes this problem and takes care of it, that's one of the decisions that you have to make as a microservice developer. So synchronous and asynchronous interaction. Now, in a synchronous interaction, service A issues a request to service B, right? Service A then suspends processing while B is processing the request. Now, it waits until service B has returned the required information before moving on with its execution. Now, in an asynchronous interaction, however, service A issues the request that is queued for process by service B, right? A then continues processing without waiting for B to finish its computation. Sometime later, service B completes the earlier request from service A and queues the result to be retrieved by A. So service A therefore has to check its queue periodically to see if a result is available. So for synchronous, is as if everything goes pari passu, right? It's a real-time thing. There's no time for breakage or a kind of wait and forward kind of thing that, okay, wait for this person, let him finish before I continue. No. For synchronous, for instance, if as well, I don't know if what we are doing now is a complete synchronous communication, right? Where we can we can talk bidirectionally without any form of distortion. However, for a case of store and forward, the case of WhatsApp can be used. Now, if you send me a message, now there may be a possibility that I'm not online, right? So the message is stored on my phone, right? So whenever I read the message, then you see some line being ticked blue that, okay, I've read your message. But some people, for personal security and sanity, you can disable the blue line. So nobody sees if nobody knows if you have read the message or not. We just know that, okay, once you have a line, the message is pending. Once you have 2 lines, the message has been delivered. But as at the time you read the message, we may not be able to ascertain that. So that's the first consideration you look at when you are looking at the communication here. Service interaction, should it be synchronous or asynchronous? Now, the next consideration or the next concern is that, should service communicate directly or via a broker or via a middleware? So this is illustrating this that condition where you have service A communicating directly with service B. Then for the indirect communication, you have service A having to communicate with the middleware, while the middleware in turn serves as an intermediary between service A and service B, right? So direct service communication, excuse me, requires that interacting services knows each other's address. Yeah. Mr. Lanita, are you guys doing something on data communication? Oh, is anybody there who can answer?
Networking. You are doing something on networking, sir. Computer networking.
And is there a subject on, is there a subtopic on data communication?
Protocols. They are analyzing protocols, different kind of protocols, layer communication, sir.
Oh, okay. I think there should be a course on data communication where you look at data packet transfer,
Yes.
duplex and non-duplex and all that.
Yes.
Okay.
They are just putting us through the protocols, UDP, TCP, packets, some things on packet, simplex, duplex, basic stuff.
Oh, okay. Then how about delivery?
Yes.
Is it delivery protocol? Successful or successful? Yeah. Okay. All right. That's good. So I don't need to bother myself about that. All right. So direct service communication requires that interacting services knows each other's address directly. So the services interact by sending requests directly to this address, our addresses. So indirect communication involves naming the service that is required and sending that request to somebody who is a middleman, right, through a message bus. Now, the message broker is then responsible for looking for the service that can fulfill the service request that you have placed on the request, right? So, excuse me. The microservice data design. Now, you should isolate data within each system service with a little data sharing as possible. If data sharing is unavoidable, you should design microservices so that most sharing is read alone with a minimal number of services responsible for data update. So I think you just put write, maybe you just shunt it so that frequent updates will not occur, so that you don't have some kind of inconsistency in your database or inconsistency in data stored in the database. So if services are replicated in your system, you must include a mechanism that can keep the database copies used. Sorry, if services are replicated in your system, you must include a mechanism that can keep the database copies used by replica services consistent. So this is where we look at data consistency and database management mechanisms. All right, so let's now look at inconsistency management. So an ACID transaction bundles a set of data updates into a single unit so that either all updates are completed or none of them are. So ACID transactions are impractical in microservices architecture. The database used by different microservices or microservice replica needs not to be completely consistent all of the time. Now, okay, well, I think all of you are muted. I wanted to ask that why is this statement correct? That database used by different microservices or microservice replica needs not to be completely consistent all of the time. Well, I think the answer is found in our introductory remark. Okay, so data, dependent data, or you could probably send in your answer on the chat. So data, okay, dependent data inconsistency. No, the action or failure of one service can cause the data managed by another service to become inconsistent. For instance, if there's a call to that microservice and it results, which is going to be sent back to the requesting or to the requester, as it's said, will become inconsistent, because if you cannot find the address, maybe you just return a 0 or you return an error, and sheepishly the other requester can just pick up your 0 as the result and continues it processing with it. So replica inconsistency. Now there are several replicas of the same service. Now, why do we need replicas? That's another question that you could look at. Okay, there are several replicas of the same service that are executing concurrently. Now, these all have their own database copy, and each updates its own copy of the service data. You need a way of making this database eventually consistent so that all replicas are working on the same data. So, eventual consistency. Eventual consistency is a situation where the system guarantees that the database will eventually become consistent. How? You can implement virtual consistency by maintaining a transaction log. I think somebody was educating us on, what's the name of these people? It's bank people that's is it interbank interaction or something, where it was telling us how an individual working in one bank can see the data of a customer in another bank. He said they have like a middle software, I think managed by central bank, if I'm correct, I'm not too sure, right? So when a database, okay, so you can implement eventual consistency by maintaining a transaction log. So there is a transaction log, right, that the banks, I think they have, that, you know, if you get to use their ATM and money is not dispensed to you, now in your maybe agitation or anger, you decide to go to walk into the bank, there's almost nothing they will tell you to do other than to go. Because you will tell them, please let me fill a form. Say no, that there's no need. Because they will just tell you that before, I think in 24 hours, there will be a reversal. So that statement reversal just means a rollback or a rollover of using the transaction log. Okay, I think there's a response here. NBBSS. Oh, thank you, Mr. Muyi. Oh, I've not seen you today. Thank you. I didn't see, when I was asking, could you hear me? I didn't hear your voice or your type or see your type. All right. Thank you. NI something. Well, I'm not a banker, so I don't need to put it to words. Thank you, sir. All right. So it is this transaction log that is used for updates. So when there's a rollover, any unsuccessful transaction will be automatically reversed. So you just get your funds back. But another thing surprises me quickly is that sometimes you can just have an error in your dispense, and in 5 minutes, they just do a rollback. So the question is that, do they do a rollback almost consistently, or they have a number of times where they do the rollover? Like, is it like every 2 minutes or every 5 minutes or every 10 minutes you do a rollover? Where there are some banks that even if you complain from one to your iteration is, your shouting is about 10 or 15 times, what they will do, they will not do any rollover to the next day or till midnight when they want to go and sleep. But some banks are quite efficient that before you go far, right, the rollback would have occurred. So how frequent do you guys do rollback? Those who are in the banking sector, please let us know. Now, when a database change is made, this is recorded on a pending update log, right? Other service instances look at this log, update their own database, and indicate that they have made changes or not. So using a pending transaction log, so you have service A and B with their databases. Now A1 with DB updates 1, A1, DB updates 2, A2, like it just continues like that up until you have an eventual consistency. So the next thing you need to consider is that how is this service coordinated? So most user seasons involves a series of interaction in which, sessions. Most user sessions involves a series of interaction in which operations have to be carried out in a specific order. This is called a workflow, right? So an authentication workflow for the UID or password authentication shows the steps involved in authenticating a user. And in this example, the user is allowed 3 login attempts, right? Yeah, who is Anu Ogunleke? Yeah, you're just getting on. You can switch up your video. Thank you. So you're driving and listening to lectures. All right, so that's blocked my screen. So an authentication workflow for this, okay, in this example, the user can now be allowed to try 3 times. You know, that's another microservice that will be delivered, that will be developed. First attempt, second attempt, third attempt, then they will now prompt you to reset your password. Okay, I think there will be an error message indicating that your login has failed. Then there can be a suggestion that, okay, you should do a recovery, maybe by sending like a sort of code to your mobile phone or to your recovery mail or something, right? Okay, I think there's another message here. Most of the banking software have a self-healing feature that does a quick check if transaction is completed successfully or not. And takes up. Oh, that's interesting. So Mr. Olusheye Oyede is writing to us. Say most of the banking software have a self-healing feature that does a quick check if transaction is completed successfully or not, and takes appropriate action. So why are some of the banks not doing that, or they just want to be very local, or they just want to be very wicked, or what do we say? Okay, so this is an authentication workflow. Well, I don't think I need to explain all this movement. You see the arrow moving. You start attempt 1. If authentication reports a fail, gets login, check login, right? So login invalid, authentication, you check if the log is invalid, authentication returns positive, login, okay, get password. So it just continues like that up until it indicates a failure after the third attempt. So this is, at least, this can also be broken into several microservices. Like the first attempt and the comparison can be in one microservice. The second attempt, the third attempt, and the error display can. So about 4 microservices can be gotten from this. So the next thing we are considering is service orchestration and service choreography. All right, so let's look at that. Login service. Okay. Oh boy, sorry. I'm a bit tired. I didn't sleep early today. I slept around 4. I woke up 5. And I've taught a class. I've attended to some other stuff. All right, so failure type in microservice system, internal service failure. Now, these are conditions that are detected by the service and can be reported to the service client in an error message. An example of this type of failure is a service that takes a URL as an input and discovers that the link is an invalid link. External service failure. These failures have an external cause which affects the availability of a service. Failure may cause the service to become unresponsive or irresponsive, and the actions have to be taken to restart the service totally or all over. So service performance failure. The performance of the service degrades to an unacceptable level. This may be due to a heavy load or an interaction or an internal problem with the service. External service monitoring can be used to detect performance failure and unresponsive services or service. All right. So when we have these types of failure, how are they remedied? So let's look at timeout and circuit breaker. A timeout is a counter that is associated with the service request and starts running when the request is made. Now, once the counter reaches some predefined value, such as 10 seconds, the calling service assumes that the service request has failed and acts accordingly. Well, maybe that's what the self-healing features Mr. Oluyede was talking about, right? So the problem with the timeout approach is that every service call, the problem with this timeout approach is that every service call to a failed service is delayed by the timeout value so that the whole system slows down significantly. Instead of using timeout explicitly, when a service call is made, we suggest using a circuit breaker. So what's the circuit breaker? It's like an electrical circuit breaker. This immediately denies access to a failed service without the delay associated with timeout. So you don't have to read maybe counts up or count down, like some of these, what's the name? This intersection where you have a traffic controller or traffic control light. Now, if the traffic controller doesn't have a sensor-based fuzzy system for for controlling, you just find out that the other part where the light is green, nobody is even passing, and it's still appearing red. Some may put countdowns there so that you see, okay, you have maybe 72 seconds to wait. Some may just have red pointing at your face that if you move, last man will carry you. So these are things that we need to look at as individuals, as policymakers. Some of these things need to be improved. Lagos is a very cosmopolitan place where you have some very terrible drivers, all those downfall guys. Now, you could have that there's traffic on the other side. So if it's sensor-based, it looks at the weighted average of each of the routes that is controlling. So the one with the highest weight is allowed to go, reducing the burden of the effect of traffic that is going to be causing on the other side. Now, this is not going to be an isolated solution. It has to also link up with other feeding roads to that location to make informed decision in a fuzzy manner, right? So this is an example of using a circuit breaker to cope with service failure. So I think that can be studied by you. So check service tool availability, blah, blah. It's just like tracing the movement, service tool available, set time out, routine service request, service tool, and it goes on and on. I need to quickly finish so that you could have time for your all right. So RESTful service. The REST representation state transfer. The REST representation state transfer architecture style is based on the idea of transferring representation of digital resources from a server to a client. Now you can think of a resource as any chunk of data, such as credit card detail, an individual's medical record, a magazine or newspaper, a library catalog, and so on. So resources are accessed via their unique URI or URL, and RESTful services operate on these resources. Now, this is a fundamental approach used in web, where the resource is a page to be displayed in the user's browser. So an HTML representation is generated by the server in response to an HTTP GET request and is transferred to the client for display by a browser or a special purpose app. So we know what RESTful means. What REST means, the full meaning, the service principle. So use the HTTP verb, then the stateless service, the URI addressable, and use the XML and JSON. So the basic method defined in the HTTP protocol, get, propose, post, delete, must be used to access the operation made available by the service. Then stateless services. Services must never maintain internal states. As already explained, microservices are stateless, so fit with this principle. So microservices can be implemented using the RESTful architecture or service principle. URI addressable, all resources must be a URI or URL with an hierarchical structure that is used to access sub resources. Use XML and JSON. Resources should normally be represented in JSON or XML or both. Other representations such as audio, video representation may be used if appropriate. So what are the service operation? Create, read, update, delete. So implemented using HTTP posts, which creates the resources with the given URI or URL. If the resource has already been created, an error message is returned. Read. You use the get. For updates, you use puts. Then to delete, you use the term delete. All right, so example, in one of the last classes we looked at, we wanted to develop a system to maintain information about incidences on a road network, so that if you are leaving your house, you would have known which area, or maybe you know your routes, you look at the map of that route. You look at incident reports that, okay, probably there's a tire burst or there's a truck blocking the road. Then you look at the estimated time for your likelihood of delay and a host of others. So the incident description of that scenario is that you have the incident ID, the date, then the time it was reported, then severity, and of course the description and expected delay will be sent to you or will be returned to you. So service operation, retrieve, add, update, and delete. So retrieve returns information about a reported incident or incidents accessed using the get verb. Add, it has information about a new incident accessed using the post verb. Update, update the information about a reported incident accessed using the put verb. Delete incidents that have been attended to or that has been cleared. So you have the request processing, service action, response generation, and the response. So this is the first, here is the response. Here is the description of this. So all we are doing is to follow this RESTful service operation. Okay. So you have the, okay, let me go back again. So you have this, you could represent them using XML or JSON. That's what, so HTTP request and response message organization, right? You have the HTTP verb, URI, HTTP version, request header, body. And the response is in this version, that's HTTP version response code, response header, then the body of the response. So this is the JSON and XML description of the incident, right? So these get requests and the associated responses. So service deployment. So after a system has been deployed and delivered, it has to be deployed on servers, monitored for problem and updated as new versions become available. So when a system is composed of 10 or even hundreds of microservices, deployment of the system is more complex than the monolithic system. So what are monolithic systems? Question. So the service deployment team decides which programming language, database, libraries, and other support software should be used to implement their service. Consequently, there is no standard deployment configuration for all services. It is now normal practice for microservice deployment team to be responsible for deployment and service management, as well as software development and use of continuous development. Continuous development means that as soon as a change to a service has been made and validated, the modified service is redeployed. So this is a challenge to some of us who are developers. So we will come up with protocol for service for microservice deployment, and that can be in Novo. Of course, it will come. We have a lot of challenges to face, maybe from just bringing it as a DJOR, then having to make it a standard that will be acceptable to all in that area. But it's something that we can give a shot, right? So deployment automation, continuous deployment depends on automation, so that as soon as a change is committed, a series of automated activities is triggered to test the software. So probably that is one way of doing the deployment. So if software passes this test, it then enters another automation pipeline that packages and deploys the software. The deployment of a new service version starts with the programmers committing the code changes to the code management system, such as GIT. This triggers a set of automated tests that run using the modified service. If all service tests run successfully, a new version of the system that incorporates the changed service is created. So another set of automated system tests are then executed. If this runs successfully, the service is ready for deployment. So this is a continuous deployment development pipeline representation like that. Then for your key points, you have this. Thank you for listening. And how many minutes we have? Oh, we have 35 minutes. All right, Mr. Olanite, please can you get the attendance now so that I can get the link to the test for them?
Okay, sir.
All right, please send in your, what's the name? Your attendance quickly so that on the dot of 2:30 or 2:35, you can start the test. It's a 15-minute test. And of course, as soon as it's 15 minutes, I'll generate my results and no other individual can get any test recorded against his name. So of course, what is composed, you see that, okay, you need to write your name and it should be surname first, right? Then you enter your matric number, then you enter your email address, right? Then once that is done, the next thing is that you proceed to answering the question. Just tick the correct one. It doesn't have A, B, C, D. Just tick the correct one and move to the next. As soon as you are done, click submit. If after 15 minutes you are not done, you are automatically logged out by the system. And of course, it will not show you your grade, but whatever you have gotten right, I'll get it in my own PB. So the test is over 30, right? And of course, and I hope Mr. Olanite has done the grouping for you guys so that we could start with our software project, and that will also be 30 marks. So we now prorate the tests to become 50, and your exam will be 50 marks. So that at least most of you can score distinction if you want. Okay, so I think I saw my long thing. Okay, I think we have just maybe 10 more people to write their names once they are done. Let's start. Yeah, I want to believe that everybody has written his or her names. Right? Yeah, so now, so let me also give you another stuff. Your questions are not going to be the same for any access time. It will never be the same. It's going to shovel questions, it's going to shovel the options for you. So you better face your work. Ah, that's too much now. I just have 74 people and I'm having more than 74 names here. Mr. Olanite was responsible for that.
Sir?
What's response? People are just joining and they are just writing their names after coming late. That's a criminal act. And of course, I had one of you saying that most of you want to drop the course. Please do. I'm begging, humbly. All right, so I assume that everybody has written his names. So I'm going to send out the address of the test. It's a Google form. Please, your name may not appear to be the first. Just make sure you go through all the questions. When you see your name, put it there. When you see your matric number, put it there. When you see your email address, put it there. The essence is to allow for uniformity, or that's on uniformity, yeah. So that one person will not be working and the other person will be dubbing, right? So I wish you the best. So as soon as I paste it, okay, let me stop sharing first. As soon as I paste it, I'll run away so that you don't come and inundate me with so much trouble. I don't get time for one. Okay, so that has been done. So coming. Okay. Yeah. Okay, let's share. Can you paste it here? Yes, I'm going to paste it here now on the chat. Okay, I'll do that too, but I'll put it on the screen first. Where's my screen? Share. All right, let me look at the time. So let's wait till 4:35 so that by 4:50 I generate my reports. And if your name is not there, that's your business. I'm not going to entertain any reports. So just 3 minutes more. Oh, sorry, my bad. I didn't ask. Do you have questions? Questions or any concerns before we move into the test? 3 minutes, 2 minutes more. Yeah, I'll put the suggestion, the link into the chat thing so that you can navigate here. There are things that you have done, they are not hard. In fact, probably I should just reduce to 10 minutes so that you don't have to start dubbing yourselves. Okay, so let's make it 10 minutes then. There are just 15 questions, so let's make it 10 minutes so that you work faster. So, coming. 10 minutes, sir. So I hope you can see my screen. Somebody's just writing name now. E-I-K-Y and Raphael something. Mr. Olanite, I hope you can pick up this fellow. Doesn't specify me. All right, so can you see my screen, please? Oh, thank you. So you can see the, okay, Mr. Muyi, thank you. Mr. or Mrs. Nifemi, thank you.
Yes, sir.
Don Zegzi, 15 minutes. No, I told you, this is time. 10 minutes is not too small. Chu Joy. Okay, thank you. All right, so this is 10, this is 4:35. So by 4:45, I'm going to generate my report. And as soon as I generate it, your time is not in. Please don't come and start saying, please, please, please. Oh, we have reached an agreement. So, gentlemen, this is your tests link. So, I wish you the best. And let's please fill it when you, even if it's the last question you have that is saying put your matric number and your name, please put it there, because I put the shovel characteristics so that you don't dub yourselves. So gentlemen, you can start, and please check the charts, it's also there. So that's the test link. I see this guy writing his name again. So that's it again, the tests. You can start. So 1 minute gone. But let me go to my box. I'm going to get it out from there. It's my phone. Mr. Abiodun, what's his name? Mr. Abiodun, like something. You are working, instead of you to do tests, you are working home. Are you reading the test like that? Okay. I don't know. All right, I think one person has submitted, and the person got 26/30. Yeah, you have 6 minutes. I just seen one submission. Five minutes. Okay, 3 responses. Thank you. So the next person at 22. Okay. 4. So Mr. Sani Sulaiman, Moibi Taiwo, Ohimina Shaun Francis, Olagunju Ifeoluwa. Seeing your responses. Okay, 10 responses. 11. 14. Please click on submit. I have 15 responses. 16. 17. Okay, so we have Olagunju Ifeoluwa, Akinkunde, Arinze. I said you should write your son name and other names. You just put Arinze. Okay. So we have 24 responses. You have 2 more minutes. And you should know that if you don't finish, it will not allow you to submit. So once my time is up, I generate my Excel sheets, and that's all. 35 responses. 41 responses. 49 responses. Okay, somebody is sending in something. Please, sir, has mine been submitted to most work we will? Let me check Thomas. What's that son name? Is your son name Thomas? Sir, submitted votes. How can I get this code? Okay, what was your name? Comment, check. Yes, I think people are submitting. Okay, what we go? Thomas Osa is submitted. Yeah, it's submitted. So we have 70 responses, and you have just 30 seconds more. I only added my son name and my dream. I said write your son name and your name. I just put that your surname should come first. That's the instruction given there. So nobody has been able to score 30 up till now. Strange. Oh, 77. So your time is, so let's give you 2 more minutes. After 2 minutes, I generate my report, and that's all. Forgot my, yeah, you forgot your matric number. Well done, sir. 1 minute more. Ugochukwu Che, you wrote only your matric number and your surname. That's not the instruction given. All right, gentlemen, thank you for your time. We have 77, no, 76. I really like online classes. It's smart. Taiwo. Oh, thank you, sir. But some people don't like it anyways. But what can we do? All right, so let me generate my report. Let's generate voting. Wow. Okay, let me see. This is very poor. Okay. So most of you are okay. Yes, I've seen nice. 22, 24, 26, 26. Wow. All right, thank you for your taking the tests. So, gentlemen, your scores are ready. The highest is 26. Yeah, so well done. That was good. Mr. Olanite, you did not do the test. Oh.
What did you say? I did, sir.
I can't see your name. Oh.
I submitted, sir.
That's why I'm looking for it. At least if anybody complains I didn't do the test, but if you complain, then I'm in trouble. That's what it means. How come? Sorry, let me check again. I am not telling you your score now. You see it in exams. Oh, whoa! Damn! Mr. Lanite, did you hack my system? I didn't even see this your grade though.
Sir.
Wow.
You got what?
1990 74 066. Hey.
Yes,
Online is interesting and everybody can see the board. And they will buy glasses now. When can we know the scores? Apologies, sir. For what now? I forgot my matric number. Who is this fellow that forgot his matric number? What's your name? I forgot my matric. Let me even see what your name is first. I forgot my matric number. Victor Ile Ugen. Is that your name? How can you forget your matric? Let me see if there's no record of matric number. Then you can, okay. Who is Olayiwola Oluwakorede Prince? You didn't put your matric, you just put 1990. Okay. Oh. Ayilara Oluwa something Alexander. Your matric number is not complete. Then I see a Buadora Ogechi. Your matric number is 09 something. It's different from other matric numbers. But I don't think the other guy forgot his matric number. There's no, okay, it's just the guy that wrote 1990. See how we can delete all those ones from here. Mine is in than everyone. Okay, all right, so thank you for your time. With this, we have come to the end of the class and the tests. And I hope that at least you have seen what the test looks like and what the exams will likely be like. So congratulations. Mr. Muyi, thank you, sir. I think I should see you in person. I just see one funny Muyi with some marks, these Yoruba marks on them. Oh, let me just unmute you guys so that if you need to say anything, you can have your floor. Mute everybody, allow participants to unmute themselves. So you have the floor.
When are you showing us the scores?
Who is talking? Oluwa.
Yes. When I was writing the test, my name auto-generated itself.
How did that happen?
I don't know. Maybe
probably you had used your name on the system before, so you just had to auto-generate.
Oh, okay.
So that's not a problem.
Okay. Thank you.
All right. Yeah, do you have any complaints? Okay, what was the average score? Okay, let me look at the charts. The average score, well, the average score, the median was 14. Yeah. Yeah, so the median, hope I've been able to answer 14. Then the average is 14.03. Then of course, the range of score is from 2 to 28. So what did I score? Oba Adekunle? I don't know. What is the lowest? The lowest is 2. Okay, who is this fellow? Please, what did you say I did? I didn't hear you well. I've forgotten. Let me check what you did. Okay, you are Olaiya. Abi? Olayiwola something, Abi? Olayiwola. Yeah, you just put 1990 as your matric number. Hope you can hear me now. Just put, sir, can you display our score? You can hide the names and display just matric number. No, that will not be fair now. I hope I am not the one that's that's got to, okay. 55. 41. Oh boy, it is well. 41, 15. Ah, okay. Aderumbi, Abi. Ade, that's the only name I can see here. Aderumbi. Mr. Ladite. Okay, oh, I have no response for you. That's all I have to say. Yeah, but I think this is a good performance. Thank you. All right, so we can now go back home and relax. Have a pleasant weekend. What's making you afraid though? Confirmation. Network was bad during this. Ah, your network was bad. Okay. Please, what this window from the show? You are no, there's no more tests now. All you have is just projects. So there's no need to prepare better. Some of you, Sha, Oba Adekunle, I greet you, sir. Don't worry, you'll be fine. That's all I know. I lost about 3 minutes reconnecting during the test when Zoom threw me out. So yeah, sorry. Mr. Olanite, probably a bookworm. That's why you are scared of your grade. Things will happen. Okay. You guys don't want to leave. It's the end of class now. Okay, let me see. Sir, my enemies. My enemies are after. Oh, sorry. I think another message came. So, okay. I lost about 3. Okay, Mr. Lanite. I didn't look at your midday. So, my enemies are after me. What is my score? Don't worry. Your enemies cannot choose you once you're in my class. You are covered. Who is this fellow? Sir, please check my score. I got up from sleep to take the test. People so matric number late. Please, scores are important. God, this fellow is quite funny. Say your enemies are after you. Don't worry, your enemies no be chase you. Come where I do. Kindly post the score. Okay, this person is giving me orders. Let me see the orders the person is giving me. Kindly post the score with the matric number so people can decide to take the course or drop it since it's an elective. I think it's only fair that way. All right, Sheyi, thank you for the orders. So you mentioned my name. Did I make mistake with my matric number? I think so. You just wrote 1990. That's all you wrote. The exams cannot be online. Championship League. I don't watch football, oh, sorry. Okay. I knew this. Thanks for the opportunity. Oh, Mr. Absalam Shola, sorry about the network. Well, I think I will check the timestamp too to ascertain if there were issues with some of you. So if you were thrown out, of course, I'll see it from here. Please help to check. Have a great weekend, sir. Thank you, Mr. Oluwatosin Dolapo. I meant OBJ, sir. Sure, there will be OBJ and there will be theory, but it's not going to be online to be physical. That's according to PG school. But left for me, I want it to be online. Yeah, thank you. Thank you. Thank you. if you do your exams, most of you will complain about networks. And that's a major issue that we want to avoid. Yeah, don't worry, you guys will be fine. You'll make up, at least I can assure you that most of you will score the extinction because if not, but I can't assure you that all of you, but at least 70% should have a distinction. That's all I know.
Amen, sir.
Yeah, so I think I'm done with your result processing now. Can now end the meeting. If 70% should have the extinction, I'm taking the course. No, do you expect to fail before? Except you don't write anything now. At least you should have almost 40 marks before your exam. So if you score just 30 over 50, that's a distinction already. I don't expect anybody to fail. Once you can speak English, you can write. That's all. Yeah, I think the result is fair generally. It's no problem. Oh, all right, so I think